Good morning all. So today we are going to discuss protein analysis in food. So determination of proteins in foods is very important one. So the analysis part is very essential in protein based foods to know the level of proteins and the quality of the proteins. Okay, so the classification and general consideration. So proteins are abundant component for biological functions and cell structure. Okay, the protein essential, it is also an essential nutrients which is very important for many biological activities and all. So food proteins are very complex. Many are purified and characterized with varying molecular mass that is range from 5000 to more than 5000 megadaltons. So composed of elements include hydrogen, carbon, nitrogen, oxygen and sulfur. So 20 alpha amino acids are involved in building blocks of proteins, and amino acids will be linked by a bond called peptide bond. So nitrogen, which is the most distinguishing element present in the proteins. Proteins are classified by their composition, structure, biological function and also their solubility. So proteins have unique conformation. So we know the 4 different structures of the proteins, that is primary, secondary structures, tertiary structures and quaternary structures. So these conformations may be altered by denaturants such as heat, acid, alkali and urea, gonadine, hydrochloric acid, organic solvents and detergents. So analysis of proteins is complicated by some food components possess similar physicochemical properties. So that is non-protein nitrogen, that is free amino acids, nucleic acids, phospholipids, amino sugar, alkaloids, that is plus lipoproteins and carbohydrate, that is a glycoprotein. So numerous methods are developed to measure the protein content, which include determination of nitrogen, peptide bonds, aromatic amino acids, dye binding capacity, UV absorptivity of the proteins and light scattering properties. So in addition, sensitivity, accuracy, precision, speed, cost of analysis also to be considered before selecting the suitable analysis method for the protein. So what is being measured and considered in selection of an appropriate method. Okay, so next is the importance of analysis. The primary objective for the analysis for the nutritional information, the background information for the product we are providing. Definitely we need to know the protein content present in the sample. So for that, analysis is very essential. So next is pricing. So based on the protein content, the price also will vary. Okay, so one of the most popular MNCs, they are selling the proteins which is highly cost in the market. So next, the functional property of the proteins. So proteins also having some functional ingredient in many foods. Okay, also it can be added as an additive also the many proteins. Okay, so for example, gliadin and glutenins, that is very important in the wheat flour. It is essential for the bread making, and casein, the coagulation of the proteins which is present in the milk. So that is also called as a cheese making, and the albumin, that is a foaming property. Okay, so the proteins which is present in the egg, so it will give the better foaming property in the cake batter. So biological activity determination, that is proteolytic enzymes present in the meat and pectinases in fruits, trypsin inhibitors in legume seeds, which will be also considered as some anti-nutrients, and also it acts as an enzymes also. So efficiency of isolation or separation or precipitation methods also important. To quantify the effectiveness of the suitable method for isolation for that analysis is important. So nitrogen based methods. So that is Kjeldhal methods. Okay, that is a main principle of the Kjeldhal methods. That is the proteins and other organic food components in a sample which is digested using the sulfuric acid in the presence of catalyst mixture, that is a copper sulfate and potassium sulfate, that is 1:6 ratio. So 1 ratio is copper sulfate and potassium sulfate is 6. So total organic nitrogen is converted into ammonium sulfate. Then digestion is neutralized with alkali and distilled into boric acid. So this borate ions are titrated with acid, and result represent crude protein content of the food. So history background. So historical background behind the Kjeldhal analysis of the protein. So in 1883, so Johann Kjeldhal, a Danish chemist, developed a basic process for today's Kjeldhal method. So several modifications improved original Kjeldhal process. So the scientists who invented the basic process by the Johann Kjeldhal, that's why the method is also called as a Kjeldhal method. So several modifications and improvements have been done with the Kjeldhal process. So original and current procedure include digestion, neutralization or distillation and titration. So general procedures and reactions, sample preparation. So sample preparation is very important in any kind of the analysis. So sample preparation for the solid foods which have to be ground to pass through 20 ml screen, and sample should be homogeneous and no other special preparations are required for the protein analysis. So first principle, the first step in the Kjeldhal analysis, that is a digestion. So place accurately weighed sample in a digestion flask. This is the image of the digestion flask. Add acid, that is a sulfuric acid, that is 10 ml sulfuric acid in all the flasks, include blank. So blank means without sample. So add catalyst mixture equally in all the flasks, including the blank tube. Then digest at 400 to 550 degrees Celsius for 2 hours, and which complete the breakdown of organic matter. So usually when you connect the digestion tubes with the heating the digestion apparatus, though it will produce with the heavy smoke. So when it reacts with the acid, that is a sulfuric acid. So when it will be connected with the aspirator with the cool tap water connection to prevent the liberation of the smoke in the environment. Okay, so which allow to cool the contents and will fume settle. So till fume settle, you should not remove the aspirator. So till that you have to wait. So then you can take the remove the aspirator, then you can take the tubes. So next so this is the image of the digestion tube. So here you can see the protein along with the sulfuric acid and heat, and the presence of catalyst, the proteins which is present in the sample is converted to ammonium sulfate. Okay, so that is a non-volatile nitrogen is formed with the reaction of nitrogen and sulfuric acid. So sulfuric acid oxidizes organic matter and ammonia is liberated. So which combines with ammonia to form ammonium sulfates. Then carbon hydrogen elements converted to CO2 and water. This is the reaction behind what is happening in the digestion process. Okay, at last end of the digestion process, all the proteins which is present in the tubes is converted into ammonium sulfate. So next, the second step, that is neutralization, or also called as a distillation. So the digested, the tubes will distill is added with the 50 ml of the distilled water with all the tubes. Then 40% sodium hydroxide solution is added, that is automated one. Okay, so if you are using automated machine, so automatically it will add 40% of sodium hydroxide, that is a 40 ml per tube it will be added. So when you add the sodium hydroxide in the tube, it turns the blue green color to black color. So this indicates the correct addition of the correct sequence of the process, analytical process. So ammonium sulfate, which is present in the tubes, is distilled into ammonia gas, and this gas is trapped into a receiver flask containing boric acid, that is 25% boric acid, along with a few drops of methyl red indicator. Initially the receiver flask appears pink in color. So when it is trapped, the ammonia gas is trapped, the change into pale or thick yellow color, which indicates the formation of borate ion. So this is the neutralization or distillation unit. So you can see the fixing of the digestion flask, and this is the boric acid containing receiver flask. So here you can see the reaction. Okay. So next, the third step, that is a titration. Okay, so the borate ion which is formed in the receiver flask is titrated against 0.1 nanometer of the HCl in the burette. So it will turns the pink in color. Okay, so how much the level of the borate ions is present, so that much amount of the hydrochloric acid it will be comes in from the burette. So when it is getting balanced, you will get the end point, that is a pale pink color. So the calculation, this is the formula. First we are going to find the percent nitrogen. So Kjeldhal analysis will not directly give you the percent protein, it will give only the percent nitrogen. Then you have to apply the conversion factor with the nitrogen, percent nitrogen, to know the percent protein. So the formula for the calculation of percent nitrogen is 14.0 and to 0.1 into TV minus BV divided by W into 1000 into 100. So this is TV means titer value, BV means blank value, 14 is atomic mass of nitrogen, and W is the weight of sample you have taken for the analysis, and 0.1, that is the normality of HCl used. And percent P. Okay, so by obtaining this value, take this value and multiply with the conversion factor. So most of the protein content will be multiplied with the 16% of the nitrogen, that is 6.25. How this 6.25 is obtained means, that is 100 divided by 16, that will give the 6.25. So percent nitrogen multiply with the 6.25. If you don't know what is the actual product which is present, in that cases you can use the 6.25 as a conversion factor. And So nitrogen to protein conversion factors for various foods that is given here. So you can select based on the major ingredient in the protein, that is a sample. You can select, suppose if you are using a egg sample, means you can use 6.25 as a conversion factor, and milk means you can take it as a 6.38. So like this, the different conversion factors for the products it is given here. You can refer this table when you're doing the analysis. So thank you. So thank you for listening the Kjeldhal analysis and the calculation part of the Kjeldhal analysis for the protein. So next class we will see some other technique. Thank you.